In this episode, we're going to take a simple idea that shows up everywhere in modern operations and make it feel obvious instead of mysterious. The meaning of common HTTP methods and why choosing the right one matters when you are driving automation or validating system behavior. When systems talk to each other over the network, they often use a style called representational state transfer, REST, and those conversations usually happen over Hypertext Transfer Protocol, HTTP. Even if you never become a programmer, you still need to recognize what a request is asking a service to do, because the method is like the verb in a sentence. The same address can behave very differently depending on whether the request is trying to read data, create something new, replace something, change a small piece, or remove it entirely. Getting this right is not about memorizing jargon, but about preventing automation from doing the wrong thing at the wrong time, which is exactly how minor mistakes turn into outages. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Start by thinking of an API endpoint like a specific door in a building and the HTTP method as the action you are attempting at that door. The door might be labeled with a path that points to a collection of things, like devices, jobs, or tickets, or it might point to a single thing, like one device by its identifier. When you choose a method, you are also making a promise about what kind of side effects are acceptable, meaning whether the request should merely retrieve information or actually change the system. This matters in operations because automation is often rerun, retried, or executed by multiple systems, and the method choice affects whether retries are safe or risky. Another helpful idea is that methods can express intent in a predictable way, which helps humans troubleshoot quickly when they see logs, alerts, or dashboards. When the intent is clear, you can separate a harmless status check from a request that might create duplicate records or delete an important resource. The method GET is the one you use when you want to retrieve information without changing anything on the server. In operations, this is what you use for health checks, inventory lists, status pages, or looking up configuration values before you take an action. A common operational pattern is read first, decide, then act, and GET is the read step. When a monitoring system asks for the current state of a service, it should be using GET because it is not trying to modify the service, it just needs the facts. Another example is an automation script that checks whether a user or machine exists before trying to create it, because skipping that check can cause unnecessary errors and noise. If you keep the mental model simple, GET answers the question, what does the system look like right now at this address? Now shift to POST, which is commonly used to create something new or to ask the server to perform an action that does not cleanly fit into the idea of updating an existing resource. If GET is reading a list of incidents, POST is often how you create a new incident in the system. In operational scenarios, POST shows up when you trigger a job run, submit a new build request, create a new record, or initiate a workflow. The most important practical concept with POST is that it often has side effects, and repeating it might create duplicates if you are not careful. That is why operators pay attention to whether a request is safe to retry and whether there is a way to make creation requests idempotent, meaning repeated attempts do not multiply results. When you see POST in logs, it is a hint that something new might have been created or some process might have been started. Next, consider PUT, which is best understood as replace the resource at this exact address with the representation I am providing. In other words, PUT tends to be used when the client has a complete view of what the resource should look like and is sending the full desired state. Operationally, you might use PUT to set a configuration object to a known good baseline, or to replace a policy document with an updated full version. This method pairs nicely with the idea of desired state because you are not asking for a small tweak. You are saying here is the whole thing, make it match. A key detail is that if you forget fields or send incomplete data, you can unintentionally wipe out parts of the configuration because replacement is not the same as modification. When systems use PUT correctly, it can be very predictable, but when used casually, it can accidentally remove settings you did not mean to touch. The method patch exists for the cases where you do not want to replace the entire resource. You only want to change specific parts of it. In operations, this is common when you are adjusting one attribute, such as enabling a feature flag, changing a threshold, or updating a label or tag. The difference between replacement and partial change matters because in real environments you often do not control every attribute on an object, and other systems may be writing to the same resource. If you send a full replacement when you only meant to change one field, you might overwrite those other updates, causing subtle conflicts that are hard to notice until something breaks. Patch, when used well, limits the blast radius of a change by touching only what you intend. When you see a partial update method in logs, it suggests a targeted tweak rather than a whole object rewrite. The method delete is straightforward in meaning, but serious in impact. It removes a resource, or it marks it as removed in a way the system treats as gone. In operational scenarios, delete might be used to remove a decommissioned machine record, delete a failed job run, clear an unused token, or remove an outdated configuration object. It is also a method that deserves extra attention because deletion can be permanent, delayed, or soft depending on the system, and automation should not treat it casually. A common misconception is that delete always means immediate destruction, but some systems implement retention or tombstones, meaning the object is hidden but recoverable for a period. Another misconception is that deletion is always safe if you have an identifier, but identifiers can be reused or miscopied, and one wrong character can remove the wrong thing. Operators learn to treat delete as a deliberate action, often preceded by a read and followed by verification. Putting these methods together, you can start to build operational stories that make the choices feel natural. Imagine a deployment system that stores records of application versions. You might get the current version record to see what is running, then post a request to start a deployment job, then later patch the record to attach the outcome details when the job completes. If the system uses desired state, you might put an environment configuration object to match the approved baseline before deploying. And when an environment is retired, you might delete the environment record after confirming nothing depends on it. The methods are not merely syntax. They describe a sequence of decisions and actions that can be audited and understood. When the verbs match the intent, troubleshooting becomes far easier because you can reconstruct what happened from request logs. A big idea that connects method choice to safe operations is the concept of idempotency, which means doing the same operation multiple times leads to the same result as doing it once. In operational tooling, retries happen all the time due to network hiccups, timeouts, or temporary service overload. Get is generally safe to repeat because it does not change state, and put is usually designed to be idempotent because replacement to a specific state should not create duplicates. Patch can be idempotent depending on how it is defined, but it can also be tricky if the patch is expressed as an increment or append rather than a set. Post is commonly not idempotent because creating a new object twice creates two objects, unless the system offers an idempotency key or a unique constraint that makes repeats safe. Delete is often idempotent in the sense that deleting something that is already gone should result in the same state, though the response might differ, and operators need to understand that difference. Another operational concern is how systems communicate success and failure around these methods, because method choice shapes what kind of response you should expect. A successful GET typically returns the data you asked for, while a successful POST might return a reference to what was created or a status that a job started. A successful PUT usually indicates the resource now matches the submitted representation, while a successful patch indicates the targeted change applied. Delete success might return a confirmation or no content at all, which can surprise beginners who expect a detailed response. The response content is not the same as correctness, though, because sometimes a system returns a success code even when the downstream effects are delayed. Operationally, that is why verification steps matter, such as following a post with a GET to confirm a job really exists, or following a patch with a GET to confirm the field actually changed. It also helps to understand that method choice is tied to resource modeling, meaning whether the thing you are interacting with is a collection or an individual item. GET against a collection typically lists items, while GET against a single item returns details of that one item. Post against a collection is a common way to create a new item inside that collection, like adding a new user to a directory. Put or patch are usually applied to a specific item address because you are updating one known resource rather than the whole collection. Delete is also typically aimed at a specific item because deleting an entire collection is rare and dangerous, though some systems allow it. When you read a request, the method and the shape of the address together tell you what kind of object is involved and how big the potential impact might be. A frequent beginner mistake is to treat the methods as interchangeable, like choosing whichever one seems to work in a quick test, without thinking about what it implies for automation behavior later. For example, using post for updates might work in a permissive system, but it can create confusion, make auditing harder, and break assumptions in clients that expect updates to use put or patch. Another mistake is assuming put is always safer than patch, because replacing an entire object feels clean, but replacement can unintentionally clear fields you did not include. Some learners also assume delete means the object cannot be recovered, which can lead to unnecessary fear or, the opposite problem, careless deletion because they think it is reversible. Method discipline is one of those habits that feels minor, but it becomes a major advantage when you are dealing with real systems where multiple tools, people, and processes interact. There is also an important human factor here. Method correctness helps teams communicate and coordinate. When someone says the automation only performs GET requests during validation, that statement carries meaning because the method implies no changes. When a change review mentions a patch against a configuration object, reviewers can focus on which field is being modified rather than worrying about a full replacement. When an incident occurs, logs showing unexpected delete requests immediately narrow the search to destructive actions rather than harmless queries. Even if you are brand new, you can learn to read these verbs as signals of intent and risk. That skill is exactly what an operator needs, because operators must make sense of systems quickly under pressure, often by scanning a small amount of information and forming the right hypothesis. To make this practical without turning it into a typing exercise, imagine a simple service that tracks maintenance windows for a fleet of servers. If you want to view upcoming windows, you use GET to retrieve them, and nothing about the schedule changes. If you need to create a new maintenance window request, you use post to submit it because you are adding something new that did not exist before. If you need to correct the entire window definition because the date, duration, and scope were all wrong, a full replacement using put could make sense if you are providing the complete correct version. If you only need to adjust one field, like extending the duration by a small amount, patch is the cleaner choice because you are changing a slice, not rewriting the whole record. And if a window was created by mistake and must be removed, delete expresses that intent clearly, and everyone reading the logs understands the nature of that action. The deeper lesson is that correct method use is not a style preference. It is part of making automation predictable, safe, and easier to debug. These verbs set expectations about side effects, retry behavior, and how state should evolve over time. They also shape how monitoring and security controls reason about traffic, because a system may treat reading requests differently than writing requests when it comes to rate limits, permissions, and auditing. When you learn to map, GET to retrieve, post to create or trigger, put to replace, patch to partially modify, and delete to remove, you are learning an operator shortcut for understanding system behavior. That shortcut becomes powerful when you see a stream of requests and need to decide which ones are normal background activity and which ones represent actual changes. The goal is not to worship the rules, but to use them to keep outcomes consistent. As you wrap this up, keep one simple framework in your head. The method is the intent, the address is the target, and the combination tells you the operational risk. Reading with GET is usually low risk. Creating with post can multiply outcomes if retried. Replacing with put can erase what you did not include. Partial changes with patch can reduce blast radius when you only need a small update. And delete demands respect because it removes things that other systems may still rely on. If you practice interpreting requests this way, you will start noticing method choices in documentation, logs, and troubleshooting notes, and they will stop looking like random capital letters. That is when you know you are thinking like an operator, because you are translating technical traffic into a story about state, intent, and consequences.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.